All right, so we did letter D yesterday. Up to letter D. All right, so you have the derivative of x, right, which we know is just 1, and then tangent of x squared. X squared is built inside of the tangent. So tangent's on the outside, x squared's on the inside. So the derivative of tangent turns into secant squared, and then the derivative of x squared turns into 2x. And then you just clean it up. So it's 1 minus 2x secant squared of x squared. All right, so this should actually be in red. And then this should be in blue. All right, letter E. How would I rewrite that? Yes. No. All right, so how would you rewrite that expression? Say again. Good. So you have x plus 1 to the negative 1, right? So what would be on the outside, the outermost function? Right, blob to the negative 1, and then the inside part would be x plus 1. So when I take my derivative now, bring down the negative 1 times x plus 1 to the negative 2 times the derivative of the inside, which would just be 1. Right. So now when I clean it up, I have negative 1 over x plus 1 squared. No, just the process you need to be good at. You could. Would probably take you longer, but you could definitely do that. Because these are all like chain links together, like this and this and that. Like all your derivatives kind of connected to one another. Imagine it like a chain. So it's the derivative of the outside times the derivative of the inside. Where you take the derivative of the outside times the derivative of the inside. All right, so I got sine squared of 3x. All right, so I want to rewrite that again. Now the squared up here in sine squared, I can now put that on the outside. So you have sine of 3x squared. Okay, so sine squared of x is the same thing as sine of x squared. They're the same thing. All right, so anytime you are asked to find the derivative where your trig function is being raised to an exponent, put that exponent on the outside because it'll be easier to figure out its derivative. All right, so how many functions do we have here that we're taking the derivative with? 3, right? So what would the first one be? Blob squared. And then the next one would be sine of the blob. And then the last one would be 3x, right? Okay, so dy over dx. I have 2 sine of 3x to the first times derivative of now sine of 3x would be what? Cosine of 3x times the derivative now of 3x. 3, right? Okay, so if I clean it up now, that leaves me with 6 sine of 3x cosine of 3x. Now there is an identity you could use to simplify this. Does anybody know what that one happens to be? No. So you have 2 sine of x. No, sorry. Sine of 2x is equal to 2 sine of x. There we go. All right, that's one of your double angle identities. So if you have the same, you're taking the same angle here, you can replace that with sine of 2x. So you double whatever your angle is on the inside, right? So if I doubled my angle, that would give me 6, right? So that would give me sine of 6x. And then looks like the coefficient out front, I divide it by, or really in half, right? Because the coefficient here is 1, coefficient here was 2, so 2 divided in half, it gives you 1. So half of this would be 3. Yeah, I mean this is acceptable, but maybe on a multiple choice question you might get this, but then it doesn't show up. Usually you have to kind of be able to look for, you know, this and this are really the same thing. The only other one is that's there is this shows up a lot. This sine of 2x is equal to 2 sine of x cosine of x. And then the other one, which I can't remember what it is. There's another one. And then, I mean, obviously you need to know this one. And then you can get the other 2 equations just by dividing that one out. And then there's another double angle identity that I can't put my head on it right now. Yes. Do you have the summer thing? Okay. Yeah, so the other one would be cosine of 2x is cosine squared minus sine squared. So these three show up a lot. Now there's like other variations of this one here, but this is the one that's like the most common. So again, just something to keep your eyes open for. So are we good? Okay. Letter G. So how would you rewrite that one? You got -5. To the 1/3. Right. Put the exponent on the outside, or put the root on the outside. Right? So now when I differentiate, I got dy over dx, bring down the exponent. So that's going to be -5 times 1/3, which is -5/3, times x squared minus 4x plus 1. 1/3 minus 1 gives me -2/3. Right? Times now the derivative of blob. Good. Okay, so just clean it up now. So you got -5 times 2x minus 4 over 3 times cube root of x squared minus 4x plus 1 squared. And the last part could be -10x plus 20. Did I do it right? Yes. X squared minus 4x plus 1 squared. So when you bring down your exponent from up here, you have 1/3 times -5. That gives you -5/3. Right? So this is going to stay in the numerator. This is going to go in the denominator. This negative makes this entire thing go into the denominator. And then this is positive, so that's going to stay in the numerator. All right? Good? All right, letter H. You got -2 over the 4th root of 6x minus 1. So d over dx, we have -2. I'll multiply that with 6x minus 1 to the -1. Right. All right, so again, work your way outside in. So when I take the derivative now, I have -2 times -1/4 would be 1/2 times 6x minus 1 to the -5/4 times the derivative of the inside, which would be 6. So it looks like I have half of 6 3, right? I have 3 over the 4th root of 6x minus 1 to fit. Good. Right, so sometimes you're going to have to use multiple rules, right? Product, quotient rule, along with the chain rule. So it's good to kind of just get practice with that. So I can't really rewrite that. Don't distribute. For the love of God, don't distribute. Because this is being raised to the 4th power. So if you were going to distribute, you would have to multiply 2x minus 3 out 4 times, and then you could distribute if you wanted to do that. That's too much work. If this exponent wasn't here, go right ahead. Distribute all you want. Whatever makes your little heart happy. But because of the 4, okay, so I have x squared, and I have 2x minus 3 to the 4th. So I have a product now of functions. And now when I take the derivative of the second guy, I'm going to need to use the chain rule to figure out its derivative. All right, so I have dy over dx. So product rule, derivative of the first would be 2x times the second. So 2x minus 3 to the 4th, plus now first times the derivative of the second, which is what? No. 4 times 2x minus 3 to the 3rd times what? 2. All right, so the derivative of the second, right, again, you're taking the derivative of the blob to the 4th, which is that, times the derivative of the inside, which would just be 2. Yes. Yes. The whole thing? So derivative of the first times the second plus the first function times the derivative of the second. So it's chain rule. So it's blob to the 4th. Derivative of blob to the 4th is 4 blob to the 3rd times the derivative of the inside now, which is just 2. All right, so let's clean that up. So I have 2x times 2x minus 3 to the 4th. I have plus, looks like I have a 1, a 4, and a 2. So that's going to give me 8x squared times 2x minus 3. Okay. We can leave it like that, or we can keep going. So what can I factor out now? I can factor out a 2x, and what else? 2x to the 3rd, good. Okay, so I'm going to multiply that now with 2x minus 3 to the 1st plus 8x squared. If I divide that by 2x, that's going to give me 4x. So now by doing that, you have 2x times 2x minus 3 cubed times, now if I simplify what's inside the brackets, what do you get? 6x minus 3. Right. So that is a much nicer answer. Again, I mean, you could stop here, but then you got to look at your answer choices and. like originally distribute, well, you'd have to multiply 2x minus 3 out 4 times, which would take a while. Yeah. All right, so now you have 3x minus 1 over x squared plus 3. So what's the outermost function? Blob squared. So we're going to have to do the derivative of that first, and then the derivative of the inside is going to require you to do, right. Okay. So dy over dx is equal to 2 times 3x minus 1 over x squared plus 3 times now the derivative of the inside. So low d high, so that would be x squared plus 3 times 3 minus high d low, so 3x minus 1, 2x, all over low squared, so x squared plus 3 squared. Whew. All right, so let's clean it up. We have, if I multiply the 2 here, right? Or maybe, no, I don't want to do that. Yeah, it's not fun that way. All right, I'm gonna do. We'll do the 2. So we'll have 6x minus 2 over x squared plus 3 times now. I want to clean up the top. So x squared plus 3 squared. So if I clean up the top, that gives me 3x squared plus 9 minus 6x squared plus 2x. And now I have 6x minus 2 over x squared plus 3 times, looks like I have negative 3x squared plus 2x plus 9 over x squared plus 3 squared. And the last part would be what? No. What do you notice here? And here? So you're going to have 6x minus 2 over, not over, times negative 3x squared plus 2x plus 9 over what? X squared plus 3 to the third. We only have so much time. We can't do everything. That would be the first step. So when you take the derivative of, you have like blob squared. So when you take the derivative, you bring down the 2. You leave the inside part times now the derivative of the inside part, which requires quotient rule. All right, letter C. We have secant of 4 minus cosine cubed 5m. So this should be an m. Okay, so I have secant of 4 minus cosine of 5m cubed. D over dn. All right, so again, put the exponent here that goes with the trig function. Put that on the outside. All right, so what would the outermost function be? Secant, right? And then you're going to work your way in, right? So secant, and then looks like the next derivative would be here, this entire thing here. Then the next one would be the cosine, and then the last one would be the 5m. All right, so 1, 2, 3, 4. All right, so the derivative of secant would be what? Right. So you keep secant of the blob, so 4 minus cosine cubed of 5m tangent of 4 minus cosine cubed 5m. Okay. I don't know. You can. Yeah. So the derivative of secant is secant tangent. So whatever you're taking the secant of, you have to take tangent has to be the same thing. No, because the angle that you're taking it with is that. So I just rewrote it like its original form. Okay. So the next part would be 4 minus cosine of 5m cubed. All right, so the first, we just did the first part, so the secant part, right? That's just straight taking the derivative of secant, no rule. Now we have to work kind of on the inside part. Now we're using chain rule, so we're just taking the derivative now of 4 minus cosine 5m cubed. So when I take the derivative of 4, 0, and then now you have negative 3 cosine of 5m squared, right? Exactly, yep. So negative 3 cosine of 5m squared. Yes, yep. Now I want to take the derivative of cosine of 5m. And what would that be? Negative sine of 5m, good. So I have negative sine of 5m. And then the derivative of the 5m would be 5. Whew. Yeah, here. Yep. So derivative of secant is here in blue. Derivative of 4 minus cosine 5m cubed is here in red. Derivative of cosine of 5m is here in green. And then derivative of 5m is here in dark blue. Yeah, it's right here. Yeah, you keep the angle the same. You did, which was the negative, which turns into negative sign. But you keep whatever you're taking the cosine of, you keep that the same. Yeah, because we were saying like you have 1, 2, 3, 4 functions to take the derivative of. In the last one, no. This is 1, 2, 3, 4. Yeah. It's possible. All right, so we have, what do we have? We got -3 times a -1 times a 5. So that's going to give me what? +15. Secant of 4 minus cosine cubed of 5m tangent of 4 minus cosine cubed of 5m. Okay, so we took care of that, and then all we have left is cosine squared of 5m times sine of 5m. Cosine squared of 5m sine, yes, of 5m. Yeah, this here, cosine of 5m squared, is the same thing as cosine squared of 5m. Yep. Yes. Right. This part is in blue. That's the first function. So you're taking the derivative of secant of the blob. The blob in this case is this. All right. So you have -3 times -1 times 5. So that'll give you +15. Yes, maybe like that. Like this and this are the same thing. I just, because it looks like more like the original. What do you mean change secant? Yeah, which is this secant tangent. That's the derivative of secant. And then you keep whatever secant is taking, like whatever angle it is, you keep that the same. So the derivative of this part is here. Because you have to keep that that's the same. So like anytime you take the derivative of secant of, say, 2x, the derivative of that, you have to keep the 2x the same. So it would be secant of 2x tangent of 2x. No matter what is inside here, when you take the derivative of this trig function, that has to stay the same for the first part. Yeah. I'm not gonna arrest you if you don't show up exactly at 7:30. Yeah, if you have homework questions.